welcome to True Projects. In this video, we are going to explain about a project titled Detection of Malicious Code Variants Based on Deep Learning. The project's introduction emphasized the significant rise of malicious code as a critical cybersecurity threat. It cites a semantic report which indicates the detection of 401 million malicious code in 2016, including 357 million new variants. This alarming statistic reflects the rapid proliferation of malware, including its presence in mobile devices and Internet of Things devices. As a result, the detection of malicious code in cloud computing has become increasingly challenging. The project's main goal is to introduce an innovative approach to detect different variants of malicious code by leveraging the deep learning technique. The primary objective is to enhance the accuracy and efficiency of malware detection, which plays a crucial role in safeguarding against security breaches, data theft, and related theft. To accomplish this objective, the researchers adopted a unique approach where the malicious code was transformed into grayscale images. These images were often subjected to analysis using a convolutional neural network, which enabled the identification and classification of images. To address this issue of data imbalance among the various malware families, the researchers also employed this algorithm. The proposed method was evaluated using the malware image data obtained from the Vision Research Lab. This experimental result showcased the commendable level of accuracy and speed, surpassing those of other existing models for malware detection. The requirements that are needed to build this project are hardware requirements: operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement: Python IDE with version of 3.7. These are the modules that are developed to build this project. The first module is Upload Malware Dataset. This module allows to upload the dataset to contents of various malware samples. And the second module is Malware Family Graph. This module generates a graph illustrating the distribution and categorization of the different malware families within the dataset. And the third module is Run GLCM SVM algorithm. In this module, the gray level co-occurrence matrix support vector mission is executed to extract texture features from the malware samples. And the fourth module is Run GLCM KNN algorithm. In this module, it executes the gray level co-occurrence matrix K nearest neighbor algorithm for feature extraction, followed by the classification of using the K nearest neighbor algorithm. And the fifth module is Run DRBA algorithm with BAT. In this module, the proposed dynamic resampling based on BAT algorithm is implemented, which is utilized to optimize the features and address the feature imbalance issues. These optimized features are then fed into the CNN model for training and classification of the malware sample. And the sixth module is Run DRDA algorithm with PSO. This module executes the dynamic resampling based on the particle swarm optimization algorithm. It follows a similar approach to the DRDA algorithm but employs the particle swarm optimization algorithm for feature optimization. And the seventh module is Accuracy Graph. This visualizes the performance of accuracy of different algorithms which we used in this project. And the precision graph. This module generates a graph illustrating the precision values achieved by the algorithms. And the recall graph. The recall graph showcases the recall values obtained by the algorithm. And the final module is predict the malware from new file. This module enables the prediction of malware from a new file or test data. The trained models such as DRBA or DRDA CNN models are utilized to classify and identify the malware family of the new file. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first file contains of the compiled Python file, and the backup folder contains the Python code, and the dataset folder consisting of the malware dataset, and the images folder consisting of the various images within it, and the model folder consisting of .h5 files. where it contains of the algorithm information and it is loaded at the time of execution of the project. And bad and malicious code test1 and test2 are the Python files, and the report is a text file and run is a bad file, which is used to execute the Windows bat file instead of executing the program in command line interface. Now to run the project, double click on run.bat file. This is the graphical user interface. With this we are interacting with the program. First we need to click on upload malware dataset button. By this, we redirect it to the dataset folder and select this file and click on open button. Here we can see that malware dataset is loaded and click on malware family graph. By this, x-axis represents the different malwares and the y-axis represents the count of each malware, and then close this graph. And click on run GLCM SVM algorithm button. By this, the GLCM SVM model is generated on the pre-processed malware dataset. Here we can see that of SVM gives the precision recall accuracy of 85%. And then click on run GLCM KNN algorithm button. Here, the KNN gives an accuracy, precision and recall of 40%. And click on Run DRPA algorithm with BAT. Here we can see the console where the epochs are running. It takes time to run all the epochs. Because the training sample is of huge size when compared to that of other projects, so the time for executing the model is to be of time consuming, takes of too much of time. And here we get an confusion matrix. As like of this, and here x-axis represents predictor class and y-axis represents of the true class of these objects, and close this matrix and click on run DRPA algorithm with PS4. And we can see the consoles of the epoch is running. And giving an confusion matrix as of like this, and use an accuracy of 99%, precision of 99% and recall of 99%, and click on accuracy graph button. Here, the x-axis represents the algorithms we used and the y-axis represents the value assigned for the accuracy of each algorithm. And close this graph and click on precision graph button. Here, the x-axis represents the algorithms we used and the y-axis represents of the value assigned for each algorithm, and close this graph. and click on Recall Graph button. Here x-axis represents the recall algorithms we used and the y-axis represents of the recall of each algorithm. And click on Predict Malware from New File button. By this, it redirected to this folder consisting of different files and select any one of the file and click on Open button. Here, the uploaded file contains the malicious code from family home and A. In this way, we can detect the malicious code variant based on the deep learning. In conclusion, we proposed a novel method for detecting the variants of malicious code using the deep learning. The method converted the malicious code into grayscale images and used a convolutional neural network to identify and classify the images. The proposed method was tested on malware image data from Vision Research Lab, and the experimental results demonstrated the good accuracy and speed compared to the other malware detection model. We conducted that their model provided an effective solution for the data imbalance problem among different malware families and that CNN was effective and efficient for identifying the malware images, resulting in significantly faster detection speed than other approaches.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.